Hello everyone, my name is Nikhil Gajjam, working as Assistant Professor in Computer Science and Engineering Department from Walchand Institute of Technology, Solapur. In today's session, we will see display function of singly linked list in forward and reverse direction using recursion. So these are the learning outcomes. At the end of the session, student will be able to write the display function of singly linked list in forward and reverse direction using recursion. So in this session, we will focus on writing the display function to print the contents of the singly linked list in forward and reverse direction using recursion. Now this is a singly linked list. We all know that in singly linked list is nothing but collection of nodes, and each node consists of two values. First one is data part, second one is a pointer which is pointing to the next node. Now in this diagram there are four nodes are there. The contents of four nodes are 5, 10, 20 and 1. Head or the start is a global pointer which always points to the first node. Now this global pointer we are using for traversing the linked list. Last nodes next we always have the null, so it is indicating that this is the last node. So there are four nodes are there in the linked list. Now the difference between singly linked list and doubly linked list is, in singly linked list each node consists of only one pointer, so that's why it is called a singly linked list. Doubly linked list we have two pointers, next and previous. So in doubly linked list we can traverse in forward and reverse direction because of there are two pointers are there, next and previous. In singly linked list there is only one pointer, next pointer, so it is pointing to the next node. So in singly linked list traversing in the forward direction it is possible because of next pointer, but traversing in the reverse direction it is not easy. We have to use another approach for displaying the contents in the reverse order. Now normal display function of singly linked list without recursion. So this is a display function. So in display function we have to use the extra temporary pointer. We have used temp here for traversing. Again we are not changing the value of start every time because start is a global pointer which always points to the first node. So struct node star temp. So temp is a temporary pointer. Temp equal to start. A temp is a traversing pointer. It starts traversing from the first node. So temp equal to start. So while temp is not equal to null, so this is an exit condition from the for loop. So printf %d temp arrow data. So whenever temp is pointing to one by one node, it will go on printing the data part of each and every node, and temp will move forward using temp equal to temp arrow next. So initially temp will point to the first node, so it will go on pointing to the next node. So first time it will print 5, next time it will print 10, next time it will print 20, next time it will print 1, and when temp will move forward, temp will have the value null. So when temp will reach to the null, it will come out of the while loop. So this is an end of function. So this is a display function. We have not used recursion here. So simply while loop we have used for displaying the content of each and every node. Now we'll focus on display function of singly linked list with recursion. Now we all know that recursion is nothing but a function which is calling itself. We call it as recursion, and the content of the recursion. Now here we have written the display function same. Structure node star temp, it is an argument we are passing for this display function. Now this is an exit condition of the recursion. We all know that in the recursion there must be an exit condition. If there is no exit condition, it will go in infinite loop. So this is an exit condition if temp is not equal to null. So it will come inside this if condition. If temp reaches to the null, it will come out of this recursive call. So this is an exit condition. So if temp is not equal to null, printf %d temp arrow data, display temp arrow next. So display temp arrow next it is nothing but next call. So we are making next recursive call, and what we are passing? We are passing the address of the next node. Okay. So how it will work? Initially we are passing start or address of the first node to the display function. This is display function. So temp will point to the first node, that is 5. So temp is not equal to null. So this condition is true. Printf % temp arrow data, it will print 5. And again we are calling the recursive function display temp arrow next. Temp arrow next is nothing but address of 10. So it will pass address of 10 to the next display recursive call. So it will print 10 like this. So it will go on printing 5, 10, 20 and 1. And after temp arrow next, one arrow next is nothing but null. So it will pass null. So here it will check the condition temp not equal to null, condition false. So this is an exit condition from the recursive call. So it will come back of this previous recursive call and return to the previous recursive call. So it will, previous recursive call is here only, control here, this is an end of function. So this is an end of recursive function. So this is a recursive function. For display function, it will print the singly linked list in forward direction. Now next function we will discuss is display function of singly linked list with recursion in reverse direction. Now we want to print the same singly linked list but in reverse direction. We know that singly linked list there is only one pointer, that is next. So next pointer we will traverse only in the forward direction. Reverse direction traversal is not possible. Now we are using a recursive call for printing the contents of the singly linked list in reverse direction. So same function we will use display structure node star temp. If temp not equal to null, it will come inside this if loop. So this is an again exit condition. Now instead of printing a printf as a first statement, now we are calling the recursive call, and what we are passing temp arrow next. So we are calling the recursive call display function temp arrow next. So how it will work actually? So this is a diagram. Starting it will will pass start address of start or address of first node to the display function. So temp will point to the 5. Then we are making recursive call. The temp will point to the 10. Then again we are calling recursive call. Temp will point to 20. Again we are calling recursive call. Temp will point to 1. Again we are calling recursive call. Temp will point to null. So when temp reaches to null, so that will be an exit condition for the recursive call. It will return to the previous recursive call. Previous recursive call is nothing but temp is pointing to 1. So when temp will point to null, it will print now. So printf percentage temp arrow data, where temp is pointing to 1. So it will print 1. And this is an end of the function. It will go to the previous recursive call. Previous recursive call of 1 is nothing but 20. So temp will point to 20, it will print 20. Again previous recursive call, temp will come to 10, it will print 10. Again previous recursive call, 10 will point to 5, it will print 5. Again previous recursive call is nothing but the calling of display function from the main. It will control will jump to the main. So like this it will print the singly linked list in the reverse direction. So we have used the recursive function for printing the singly linked list in the recursion in the reverse direction. So program, we will execute this program. So we have an online compiler here. So we have used online GDB for executing the program. So this is the program of singly linked list. Here we have an display function here. This is insert at beginning, insert at end, insert after. This is display function. So this is a normal display function. It will print the content of singly linked list in forward direction but without recursion. Same code I will use. Okay, just a second. So what we are passing, structure node star temp, and from main for display function we are passing start. Just execute this. Okay, if temp is not equal to null, okay, just a second. T3. Okay. Okay, we'll execute this. First insert at beginning, I will enter 10, then insert at beginning again, I will enter 5, then insert at beginning, I will enter 2. So I will call display function. So display function is 2, 5 and 10. So we have print the singly linked list in forward direction. The same code we will use for displaying the contents of the singly linked list in reverse direction. So where we are making changes. So instead of printing first we will call first we'll make the recursive call and then we are printing. So this is your printf %d comma temp arrow data. Then you'll execute this. Insert at beginning 10, insert at beginning 5, insert at beginning 2, and then we are calling display. So it will print 10, 5 and 2. So normal linked list in forward direction, 2 is the first node, then 5 and then 10. So we have print in reverse direction. So first it will print 10, then 5 and then 2. I will come back to PPT. So you can pause the video and you can answer. What if we don't have the exit condition in the recursive call? The answer is segmentation fault, because there must be a recursive call. There must be an exit condition in the recursive call. If you don't have the exit condition, it will go in the infinite loop, and it will print in this program. It will print a segmentation fault as an error. So these are the references I have used. Thank you.